Alright, this video is going to look at even more examples of limits at infinity. And as we go through here, you may want to actually pause the video to see if you can determine the limits on your own before I work them out. So here we have our first example, 5x cubed minus 3x squared plus 10 all over x squared. And remember, all we have to do at this point, if we're looking at the limit as x is going to infinity, is we know if we plug infinity in, we're going to get infinity over infinity. So we can use our little shortcut and simply compare the largest exponent in the numerator with the largest exponent in the denominator. And here, the numerator is larger. So what does that tell us? That means the top is going to infinity much faster. So that means our limit is going to go to infinity, which means it does not exist. All right, example number 2. If you notice, we have basically the same problem. Again, 5x cubed minus 3x squared plus 10, all divided by x cubed plus 4x squared. And once again, if we're looking at this limit going to infinity, all we have to do is compare the exponent on top with the exponent on the bottom. And in this case, they are the same. So our limit will be the ratio of the coefficients. So this would be 5 over 1. So therefore the limit is 5 over 1, or simply 5. And if you notice, once again, our next example is very similar as well. We have the same numerator, but now we're dividing by 7x to the fourth minus x. And once again, we simply compare the exponent on top with the exponent on the bottom. And in this case, the exponent on the bottom is bigger. So that means the denominator is going to go to infinity faster. So if you have a number over a very big number, then our limit is going to equal 0. Okay, this example is a little bit different. We have a square root in the denominator. So we have 2x over the square root of x squared plus 3. And one way we can think about this is, again, in the scheme of things, x going to infinity, this plus 3 on the bottom really is not going to change the problem that much. So if we kind of think about ignoring the plus 3, we could think of this as being 2x over the square root of x squared. And if we think of taking the square root of x squared, then you're left with 2x over x. And at this point, you can think of, you can compare the exponents. You can think of it that way. They're the same. So the coefficient would simply be 2 over 1. And therefore, our limit would be equal to 2. Now, the next example here is identical, except for notice here, we're looking at the limit as x approaches negative infinity. And we can go through kind of the same steps. We can think of this as 2x and kind of over the square root of x squared. And we would be left with 2x over x. And we know, once again, we're going to end up with this answer of 2. But we need to be careful because of the negative sign. It's kind of like if we were to put the negative here in for, if we look at this first term here where we have 2x over the square root of x squared, if we look at it here, I think it's easier to understand what's going to happen with the negative. For example, if we were to just look at the negative and ignore the infinity part for now, if we plug a negative in for x on the top, you would have 2 times a negative. And on the bottom, we would have the square root of a negative x, or we could just think of it as the square root of your negative sign squared. So what's going to happen is 2 times a negative is a negative 2 over a negative squared. That means the denominator is going to be positive. So in this case, a negative and a positive, that means here the limit is not positive 2, but it would be a negative 2. Okay, so make sure you note the difference here. You need to be careful with your sign if we're looking at the limit as x goes to infinity or if x is approaching a negative infinity. And one way you can always double check yourself, keep in mind you can always graph the function and determine and verify that it is approaching, in this case, a negative 2. Or the one above here, you could graph the original function, and you can see as x gets very big, your y value is approaching a positive 2. So keep that in mind. You can always double check yourself graphing the function. Okay, once again, we have another example, 8x cubed plus 4 over 12x cubed minus 6x plus 4. And hopefully you're getting the hang of this. We can simply say, well, we have a 3 on top, a 3 on the bottom, and that means they're equal. So we're going to compare the ratio, or the limit would be the ratio, 8 over 12, which will reduce to 2 over 3. So really, once you get the hang of these limits at infinity, they can go rather quickly. But once again, be very careful with your signs. As in the next examples here, we have the limit of 1/2 x minus 7 over x squared. And once again, we're looking at the limit as x is approaching a negative infinity. So now, because this is subtraction, we can think of this as two separate limit problems. So we could simply look at 1/2 x. Well, in this case, there's no variable in the denominator, so we have 1/2 x. What's going to happen there is that's going to go to infinity, and if we plug a negative in, this is really going to be equal to a negative infinity, isn't it? 1/2 times a negative infinity would be negative infinity minus 7 over x squared. Well, we know that 7 over infinity, that's going to actually equal 0. And now be careful, we know that the negative here is negative infinity minus 0. So if we subtract that, we would have a negative infinity. And once again, that means our limit does not exist. Now, if you look closely at the next example, it's the same problem, except for notice I switched the 1/2 x and the 7 over x squared. So it's now 7 over x squared minus 1/2 x. And we're still looking at this limit as x is approaching negative infinity. And I'm working this one because I want you to notice what's going to happen here. We're going to have the 7 over x squared, which we know that's still going to go to 7 over infinity. So that's going to still approach 0. And then it's minus 1/2 x. Well, from above here, we know that 1/2 x, if we plug in negative infinity, that's going to a negative infinity. Now, we're looking at the whole expression here, so that means we would have 0 minus a negative infinity, and the two negatives here would make this positive infinity. Now, it really doesn't matter at this point, but we want to be specific here. This would be a positive infinity, but overall the limit still does not exist. Okay, so once again, be careful with your signs, particularly if you have negative infinity and with the subtraction in your problem. All right, here we have our final example. The limit of negative 3x plus 1 over the square root of x squared plus x. And again, you may want to pause and see if you can work this one out on your own. We looked at a couple dealing with this square root function. So if you've taken some time here to work this out, if we look at this together, once again, we could think of this square root on the bottom. Again, x squared plus x, even though this is a variable, adding the x, when you think of this going to negative infinity, we really can kind of ignore this and think of this as negative 3x over the square root of x squared. And like we did before, we could think of this as the square root of x squared would simply be an x, and our exponents here are the same. And we know the ratio then would be negative 3 over 1x. So therefore, it looks like our answer would be negative 3. Now, do you think that's correct, or what else do we need to double check here? Well, remember, we were looking at this limit as x was going to a negative infinity. So once again, I think it's easier to look at if we go back to this step, and if we figure out what's happening with the negative sign. Well, on top, we would have negative 3 times a negative over the square root of our negative squared. So on the top, the two negatives make it a positive 3. And if you square the negative on the bottom, that's also going to be positive. So we end up with 3 over 1. So therefore, this is going to turn out to be equal to a positive 3 for your limit. Okay, so be very careful. I know at a first glance, you'll look here and say, oh, well, negative 3, and you think the x squared and the square root cancels, and you look and say, oh, it's a negative 3 over 1. But keep in mind, we're looking at this limit as it goes to negative infinity. And keep in mind, once again, to double check yourself, you can always look at the graph in your calculator.